right, guys, we're going to go on and get started. And what we're talking about today is kind of a parent of functions, or just different parent functions are kind of the general functions that we have in their most basic form. Now, the first one we're looking at is linear and squaring functions. So these are kind of goals to enable you to recognize basic shapes of the graphs and the different types of functions that we can have. For instance, any function that comes in the form of ax plus b is going to be a linear function. And this is just the general form of any and all linear functions. Linear. Ax plus b. And you're normally used to seeing it as y equals mx plus b, where m is the slope. We can call it a, as they say here. And we can note different parts of it, the fact that the domain is going to be the set of all real numbers, where as long as the range is not equal to 0. And we can have it in this form here. Well, we can also write a linear function from these points, because if given 2 points, well, f of 1 is just talking about y. So when we plug 1 into x, smaller one, we get a y value of 3. When we plug 4 in for x, we get a y value of 0. So all this is really saying is that we have the point 1, 3 and the point 4, 0, and we want to find the equation of the line. Now, if we wanted to do this here, we could find the slope, y2 minus y1, so we'd subtract the y values, 3 minus 0 over 1 minus 4. Well, 3 minus 0 is 3, 1 minus 4 is negative 3, so we get a slope of negative 1. At this point here, we can use the y minus y1 equals m times x minus x1 to find the equation of the line. And we can pick one of these points. So we could pick the point 4, 0. 0 for our y value, negative 1 for the slope, x minus 4. Then when we solve this here, well, y minus 0 is just going to be y. We distribute the negative. Negative 1 times x is negative x. Negative 1 times negative 4 is going to be plus 4. Questions on this here? We good with this here? All right. Now the next one we can have is the constant function. Constant function is just going to be a straight line. Y equals, we'll call it C. They call it C, just a number. And it's a flat line. We have this here. Or it could come in the form of f of x equals x. Linear. Our squaring function, or we can call it the quadratic, is this here. Squaring is just saying y equals x squared. So any one that comes in this form here will be a squaring function or a quadratic function. The domain is still all real numbers. The range is going to be the set of all negative numbers, all the numbers greater than 0 in this general form. The function's even and the graph intercepts at 0, 0. We have a U-shaped graph. Now we have some others. We have cubic function, our x to the third. And this here, the domain and range are both going to be the set of all real numbers. It is an odd function, and it intercepts the graph at 0, 0. So it's this kind of S, sideways S-looking curve is kind of our cubic function. Got any questions on this so far? We have the square root function, f of x or y equals square root of x. The domain of this function is the set of all non-negative numbers, non-negative real numbers, and the range is going to be the set of all non-negative real numbers. Intercepts at 0, 0, and the range is increasing. because we have this shape here. And even though it doesn't look like it'll eventually go to positive infinity on the y-axis, it does keep increasing as we go further along. It's not at a fast rate, but it does take a while. It will eventually get there. We have the reciprocal function. Y equals 1 over x. F of x equals 1 over x. Now the domain is pretty much everything except 0, because I can't have 1 divided by 0, but I can have any other number. Now the range for this function is also -0, pretty much everything except for 0, because there's no way to make this function equal 0 either. The function is odd, the graph does not have any intercepts, and the graph is descending on the interval of -infinity to 0 and 0 to infinity. And that'll make sense when we actually look at the graph. And the graph is symmetric with respect to the origin. Well, let's see what the graph looks like. And we have this here. Because as we come from the left, this is decreasing. It is getting smaller and smaller. But it has an asymptote at y equals, or x equals 0. So that line, it'll never cross it. It will never intersect it. But then the function jumps up here as we're going and continues coming down. So it's decreasing on this interval. But we would have to exclude the 0 because it's not actually there. There's no point for this function at 0. Questions on this here? Step and piecewise functions. Now, up to this point, because piecewise functions you've dealt with. You've dealt with linear, constant, squaring, cubic, square root, and reciprocal. Y'all have done all of these here, yes? The one that's going to be new is the step function. Functions whose graph resemble a set of stairs are known as a step function. Yep, that's it. Is the step function here. It's the greatest integer less than or equal to x, whatever the value is. So -1, if we take the step function -1, the greatest integer less than or equal to -1 is -1. For -1/2, the greatest integer less than or equal to -1/2 is -1. We drop down to -1. Now, the greatest integer less than or equal to 1/10. So what's the first integer less than 1/10? 0, because it drops back to 0. 1.5 is going to be 1. 1.9 is still 1. Really, for the most part, with whole numbers, if we're going up as a decimal, we're dropping the decimal off. With integers, we're going up. And this here is the graph of it for the step function, because it looks like a set of staircases. The range of the function is the set of all integers, because we don't have anything between any of our numbers, because between 1 and 2 for a step function doesn't exist on the range. It's just the integers. The graph has a y-intercept at 0, 0, and an x-intercept at 0, 1, because all the points between 0 and 1 actually are on the x-axis. So it has more than one x-intercept. But it does jump from point to point. So if we wanted to evaluate this step function at these values, because I think this would be helpful to see, we can start off with f of -1 is equal to the step function of -1 plus 1. Well, the step function value of -1 is just -1. Plus 1 is 0. So it really didn't change anything. if we looked at f of 2. Well, that's the step function of 2 plus 1. Well, the step function of 2 is still just 2, and 2 plus 1 is 3. Questions on this here? Now the step function of 3/2, well, 3/2 as a decimal is 1.5. Well, that'd be the step function of 1.5 plus 1. Well, what is our step function value of 1.5? 1 plus 1 is 2. Questions on this here? Let's look at another. Let's say f of negative 2.6. So that'd be the step function value of negative 2.6 plus 1. So for this here, what's the step value of negative 2.6? It'd be negative 3, because we're looking at the value less than it. Now, and this is, again, there's a reason I chose negative 2.6 or a negative number. Because with most positive numbers, not most, all the positive numbers of the step value, we're dropping that decimal. Because again, one more. Because by definition, it's the greatest integer less than or equal to whatever the whole number is, or whatever that value is. So greatest integer less than or equal to negative 1/2. So we're going less than it. Well, for negatives, the numbers that are less than a negative is a bigger negative number. We're going in the opposite direction. So for us, when we're looking at negative 2.6, I think is what I said, we're looking at a value here, which is coming down to our negative 3. So this here would work out to be negative 2. And luckily they did give us a graph here of this function. So negative 2.6 would be here, which corresponds to the y value of negative 2. Does this kind of make sense? I mean, it's funky. It's funky how this works, but that's how this is. Questions on this here? And these are some of the commonly used graphs for these parent functions, and it's nothing, these here are nothing new. Because we've got the quadratic, the cubic, reciprocal, the greatest integer function or our step function. All of these are kind of the basic forms of them. And that's it.